you all very much. I'm Laura Taylor. I'm a postdoctoral scholar in social studies here at Caltech. And some of what I'm about to talk about will be familiar from the previous presentations. And I think it's kind of interesting because, we did not coordinate these things, but we're all sort of coming at similar challenges from different perspectives. And so I actually think it's really helpful to hear how we're engaging with these different measurement issues from some of the same data sources. Okay, so just from a broad perspective, social scientists are in part focused on mechanisms for human adaptation that can yield both useful knowledge and more efficient social responses. Now, this requires actually understanding the pattern of how humans behave under different environmental and institutional conditions. Trade-offs, right? How do we use our water? Why do we choose these different attributes? Why do we act the way we act? If people haven't been to the Hoover Dam, by the way, you should go. So these are inherently empirical questions, and social scientists who study water quality seek to understand how such a pivotal natural resource exists, is used, and is damaged or not within our societal structures. So in this talk, I'll introduce some of the questions that I find important and interesting, and address key challenges in social science water quality research, and highlight measurement issues that scientists and the community can help with. So, to the bigger question of how do humans and our societies interact with water resources, for me, I look at surface and groundwater, so I'm not oceanic. But I look at this really from two sides of a coin. So on the one hand, how do our social structures, behaviors, and actions impact surface and subsurface water resources? And to that point, how do our institutional frameworks and social policies either exacerbate or ameliorate water quality issues? On the flip side, and we heard about this in the keynote a little bit yesterday, how do water quality conditions such as aridity, salinity, pollution, and other factors affect human behavior and social organization? And so there's a long history of scientists and social scholars who have thought about these issues from both qualitative and quantitative perspectives. And again, in the last few decades, we've begun to collect and have access to many more types of data that can help. So we learned a lot about that yesterday, especially. My goal is to answer these questions specifically with empirical information and formed by a deep understanding of both institutional and scientific underpinnings. So some examples of the kind of bigger picture institutional questions we might be interested in are, for example, if we want to understand how the laws of prior appropriation, basically what governs most of water use in the Western United States, impacts water usage, can we measure something empirically about the impact of this legal framework on actual usage? What about on over or under usage, or on crop development as a result of these institutions? Another question we might ask that I've tried to ask is, do our administrative processes that we go through to allocate water or use water, do they themselves engender unintended consequences in terms of pollution? So a specific question that I've looked at in my research is, does the highly political and highly contentious process of adjudicating federal tribal reserve water rights in Western states lead to increases in pollution around these reservations, particularly upstream, or strategic over or underuse of water resources during these negotiations? We might want to know, how do people view the long-term security of their water rights? Because this is going to impact how they use their water or how they may or may not transact for water or trade these rights. And how does it impact decision-making, water use, and policy initiatives in the present day? So amongst others, we might care about these questions so that we can address challenges from this institutional standpoint, design better policies to reduce incentives or to pollute or overuse water. Or we might just want to know and understand the state of the world we're living in. And that sort of sounds like a catch-all, but it's really important and it's really hard to get at. Especially, we might have a lot of intuition about policy or expectations about policy, but what we would really like to know is empirical evidence of truly what our policy is doing and how people are behaving. So, of course, data can help answer the questions at hand. But empirical analysis requires both control groups and treatment groups and randomization, and that's just a lot of data. So for the example of whether water use and pollution increase or decrease with these high stakes negotiations over water, I'll just give a little brief example of these challenges. So some data that can help, this gets at what Anna and David were talking about. The EPA has this incredible resource of data, over 300 million observations, called STIRET, that was originally created in this mainframe computing environment, and it houses data on pollutants and stream flow taken at latitude and longitude points for the last century. Of course, the US Geological Survey has mapped every flow line, stream, and river in the United States with some information that you can use to network the direction of these stream flows. Of course, we have weather and climate data, we have institutional data, we have economic data, we have demographic data, we have all kinds of data that relates to this question. So in theory, we have a lot of data. These are some familiar pictures from the last few slides, but I'll sort of point out some things that complement what others have said too. So on the left, the little dots there are those latitude and longitude points from the STIRET databases. They're very small, so you can kind of see. One thing that may jump out at you initially is that they're obviously not uniformly distributed. There's a selection in terms of where people are taking these measurements and where they're not. But we still might have pivotal questions about water use, pollution, and quality that we want to answer on a more uniformly distributed basis. The shaded peach areas are American Indian federal reservations. And so in trying to understand, how these giant negotiations affect stakeholders around these reservations who are using these waters, it's helpful to start to map out the state of the world around them. And of course, we can overlay streams and rivers and other kind of information. But in reality, there are several challenges. So this is a zoomed in picture of the northeast corner of Arizona. This is Navajo and Hopi reservations here, and these little latitude and longitude points. In reality, it's virtually impossible to get data on water quantities people have been talking about. Water use is very, very difficult to ascertain. It's a primary important piece of information. Harmonization across geographies, as Anna mentioned, is very, very difficult. For context, some people asked about the time of the study that you had posted. For me, for example, parsing through those 300 million observations using the raw data required the use of a supercomputer and parallel programs and lots of processing equipment just to sort of open and clean the raw data, not to mention learning chemistry and trying to harmonize on those metrics and getting rid of observations that had typos or weird things, finding errors from the mainframe coding. That was all a long process. So cumbersome data and intense processing requirements, especially also then in networking flow lines, because a lot of the tools, and I'd love to talk more with Kate about this, a lot of the tools that are sort of off the shelf and easy to use are not built for this granular kind of varied range of questions people might be asking. So, there's not an off-the-shelf tool for networking from a reservation boundary what streams and rivers are upstream or downstream. So that's just some challenges. We'd really love to know how pollutants change and degrade throughout different geographic conditions. And also, as we discussed yesterday, there are these complicated diversion mechanisms like infrastructure that are very, very hard to understand and model. So if we are trying to ascertain something about use, it's really difficult to know if water is extracted one place, where is it used in another place. And this is a really important economic kind of social behavior question. Also, we have institutions that can exacerbate problems with measurement and data, especially institutions that encourage obfuscation. If you ever go to Yuma, farmers there will not tell you how much water they're using. They'll also, I've been to Yuma, they show you their cannons from when they started the militia to fight California over their water rights. They will use them again. They make you aware of that. They're also very friendly, and dates and movies are really good. But okay, so coming back to this economic social science research, again, we often don't have a lab setting that we can analyze this information in. So social scientists really rely on exploiting real life scenarios of variation and randomness. So this means that that sort of pattern of kind of selection of even where these monitoring stations are is problematic. Many environmental factors lend well to this kind of setting, like weather, or temperatures, things like that. But for water, there are not a lot of on-the-ground data that are both highly granular and over a time period that spans policy, economic, demographic, or social shifts. And also to Hannah's point about different time frames, in that STIRREP data, you could have one latitude and longitude point where you will get intraday readings, like there's a really active person monitoring at that station, but then another one where you get 1 in 10 years. So there's just not a lot of harmonization in that way. And we need data that spans policy, economic, demographic, and social shifts because we're merging the scientific and the social situations. There are very good measures in some localized areas, but there are not easy ways to harmonize those over a broader range. And even though the promise of remote sensing is very exciting and has helped to provide a gridded span of information, it's only in recent years that this data is available at both high granularity, high frequency, and wide geographic coverage in a time frame with high enough frequency to provide this temporal variation. So again, as social scientists, we have all of these questions that have occurred in the last century that we'd really like to answer. So it's super exciting that there's new satellite data, but it's, I'm impatient. I don't want to wait 10 more years for some economic thing to happen so that I can use it. So hopefully we can maybe go back and make those historic estimates from the better remote sensing data. So my final slide is just some questions that scientists and engineers could help answering. Some of this is repetitive from other people, but I'll just sort of say it again from my perspective. It'd be really great if I could wave a magic wand and have water use data. I would love that. This is partly an administrative and institutional problem. It's partly a measurement problem. It would be great to have more information on how pollutants flow through the hydrologic network and through different geologies in a way that results can be implemented into social science research. So, like, what does it mean if I see increases, in people calling more upstream of a point of interest? How does that degrade through that specific geology that I'm looking at? I would love to know the full robust network of diversion infrastructure and whom do they deliver water to in the Western United States. So where are people actually using the water that they divert and how much is being taken from streams and rivers? This is part a policy problem and part a measurement problem. I know that this is already in part underway, but I believe NASA JPL has started to take steps to provide this kind of thing with their Western Water office. But it'd be great to help build a centralized and standardized network of harmonized water data that we know is of good quality. It would also help to ground truth satellite data for more characteristics and locations so that an economist can know that the satellite data is accurate to a certain level. And then it would help to guide practitioners in practically applying remote sensing data and understanding assumptions. And again, knowing that when we want to use remote sensing data, again, it's not just that we want to use it for a state or just a big aggregate region, but we might have very specific asks of location variation that we need to know on a very small scale, or as small as possible, some of this information. And I think the last thing I'll end with, I said at the end to have consideration of future cultural and privacy issues. I think this is the point. I really liked Kate's slide yesterday of the graph showing technological change and implementation and understanding at two different slopes, because there are going to be, I'm sure, and I'd be curious what political scientists think, there will be pushback from wealthy landowners and farmers in California against using remote sensing data to say how much water they're using. And there are real privacy concerns and cultural and sort of sovereignty concerns about the use of this remote sensing data going forward, and maybe how we can think about that from the ground floor before these things sort of get beyond our ability to control or address. There are great great, exciting things that we can gain from them, but I think it's probably important to also talk about the human realities of how they will impact societies. So that's that. Thank you very much.